Hey everyone, welcome. So in this video we are going to do the third part or the third module where we'll be adding our model to our canvas. Okay, so you remember we have built this model and we got our model, we have saved it here as model.pt. so I've just got this model.pt here. Okay, you remember from the first video that we have created this canvas.py, something like this, and here we had this predict digit function and we use this predict digit function to plug in this model. Okay, so we can do two things: either we can import this model in this canvas itself and then in this file only we can use this model, but that will not be very accurate because usually what happens, you want to keep your front end side apart from your backend or modern side. Okay, so that's why we use our API as we do in real life scenarios. So we'll use an API. Let me create a file here. Let's say, what should I name it? Modern server. That modern server.py. Okay, so in this modern server.py we'll import this model and we'll create an API endpoint with the help of FastAPI, so we can hit that API from here, from this predict function, and we'll also send this image to our API, and our API will get that image, predict that with this model, and then send back the digit which this canvas will show us. Okay, so this model.pt function is just this which we have saved here. Okay, so let's begin. So I'll first import some obvious libraries like numpy. Okay, import numpy as np. We need FastAPI, so yeah, import FastAPI from FastAPI. Also, yes, we need HTTP exception, but we also need upload file and file. Fine. Then we'll do some other, like we need our pillow library, right? We need image and we need image ops. Okay, we'll import IO, that is fine. We'll import request. So request we won't need here, we need request in our canvas.py. What else we need? We need torch library, right? Because we are going to use a PyTorch model here, so we need to import torch and other like torch.nn, which we have done in previous video. Okay, we can do matplotlib also if we need for it, for seeing the images that what we have got, and also we need uvcon, so we'll import uvcon. Fine. We can import os also, so we can give this path of this model. Okay, after that I'll initiate an app that will be this FastAPI app. Okay, and then what I do, I'll simply go here. So what we need to load this model now. Okay, and I'll create a function def load model. Okay, and I'll use this os library to get the path of the model. Okay, so os.path.directory name, this will give us current path of this current directory, and then we'll have this modern path that will add this current directory, and we can, instead of giving this name directly, we can have a parameter here, let's say file name or model name. Okay, sorry, we can have a modern name, and here we will do what? We'll add our file name, that is the modern name. Okay, and we'll add a pt here, right? Because this here is this pt. Okay, yeah, we can add this, that if this modern not exist, it will give us modern does not exist. Fine. Next, what we'll do this modern loaded is equal to torch.node modern path. Okay, this modern path map location. So in this torch we need to set the location, because this is I'm doing it on my local system and I don't have a GPU in my local, so I'm using CPU here. And then waits only. So waits only is what? That when we were saving this modern, right, this modern, we could have saved the waits only, which we need to so waits are saved as a state dictionary, that is called, but here we have just saved the entire model. Okay, so for that waits only is false, so we'll just do false here. Okay, we could have saved the state dict also, that would have been fine. And then we'll set it to event mode, as we have seen in the previous video, that whenever we are doing the inference, we need to set our model in the event mode, and then we'll return this model. Okay, and let me call this function now. So modern is equal to node model, and what is our modern's name? It is just model. Fine. Now what will happen when this model will be loaded? It will search for its class. Okay, so for that what I'll do, I'll just go here and just copy this class from here and simply paste it here. This is it, nothing else. Okay, we'll import this. So from torch dot, you know what, from torch dot nn dot functional, or we can just import the whole thing. Import torch dot nn dot functional as f. Okay, but we have imported this same thing in our previous directory, so this here we are using f here, right? Previous video, not previous directory, where we have loaded trained this model. So we have this our structure of our CNN model, and a function which will load our model, this modern.pt, which is our train model. Fine. And also we have created an instance of our FastAPI here. Okay, now we'll create a endpoint for our API. App.post predict is fine. Okay, why we are using post here? Because we'll get a PNG file or an image file or JPG or JPEG, as it is suggesting. I'm just reading them, and so that's why. Now I'll create a async function. Okay, so async function, because we are using APIs. I won't explain why we need to use async function for APIs, that you can read up. And then we'll put in a try catch block, so if any error comes, our application doesn't crash. It will give us a already predefined error. Okay, so let's do that. Try. So what we need to try, we need to get our image. Okay, so this file which we have taken from this predict function, which we get from this endpoint, that is predict, with the help of this post method, that will open. So we'll do this image dot open, and we'll use this io dot bytes io. I'll tell you why we are using it. okay, when we pack it. Okay, here we are unpacking this image with the help of this io.bytes.io. When we go in the canvas.py and pack it and then send it, then I'll explain what this io.bytes.io do. Okay, then we do this await file.read. So obviously a sync, if here is a sync, here we use a await function, and then we convert it to our grayscale images. Okay, and then we resize it into our 28 cross 28, that is our MNS dataset size. Okay, so you have a question that why we are converting it into this, why we are doing this 28 cross 28, because we are already getting, we have written here code which the images were already in that shape, right? They were already in grayscale because we are creating it like that. And why we are also giving this image size here at 28 cross 28. So why we need to do it again? So cause we are using an API, right? So from when we send a image from here, we'll create an array, kinda like this bytes.io array, that will be just numbers in a sequence, right? So it will just like a long array, and then again we need to tell our model or our image that what kind of numbers they were, or what kind of image we need to create from those numbers. So that's why we are again using n here, that we are telling this image function that okay, those numbers which you have got, those were of type grayscale and of size 28 cross 28. Okay, then we'll do this contrast thing, if you remember from the last video. So we did this auto contrast when we were training our model, so we'll do that here. And what I do, I also save this. Okay, no, I don't want to do this, it is already 28 cross 28. What I'll do, I'll save this dot save as a temp image.png, or yeah, png is fine. Okay, then we'll create an numpy array from this image contrast dot and type np.float 32, and we'll just normalize it with this dividing by 255. Fine. Instead of doing it here, we'll save it here. Okay, so pnt dot im show image array cmap is equal to gray. Okay, pnt dot access off or on, it doesn't matter, but okay. And then we'll do pnt dot save fig temp image dot png. What's happening? Fine. And we also need to specify the cmap, but fine, good. Now we'll create an image tensor from this, cause we were using PyTorch, and for PyTorch we will need PyTorch tensors. So that's why, and I need to stop pressing just tab. Okay, so we have created this image tensor with this image array, and we're doing this unsqueeze and squeeze. So if any extra dimensions are there, that will be cause this will be 28 cross 28, right? So we need that one extra dimension. You remember the size of an image were 1 cross 28 cross 28. That's why we are doing this. So we are adding a channel dimension that will be 1 cross 28 cross 28, and this will be our batch dimension. So you remember we were using 64 batches of 64. So our model is used to take inputs like that. So whenever we were training the model, our input to the model were batch size, comma, channel, that was one only because we were using grayscale, and then 28 cross 28. right? So the shape of that was 64 comma 1 comma 28 cross 28. So cause here it is just 28 cross 28, so we need to add that 64, that will be 1 only, cause we are predicting 1 images instead of 64, and another one, that is the channel. So that's why we are doing here these two unsqueezes. Okay, next thing, we use with torch.nograd obviously. So because we don't need any gradient to accumulate while we are doing inference or predictions. Output will be modern of image tensor, so this modern which we have loaded here, and then we have predicted torch.max output comma 1. Yeah, this can be done fine, and this prediction is equal to prediction dot item. So we will have a number or image, that will be our predicted digit, and then we will simply return this. Okay, so yeah, again I don't know what is this with indentation. So we'll return this prediction. Yeah, we'll do this predicted digit is prediction. Fine, let me do an int also here. Okay, and we don't need to send this thing, we'll just send our prediction image. Cool, and then we'll use our accept, that will be rage http exception. Okay, and now why is this okay? Let's see, this it's coming here only, right? And this seems fine, this seems fine. Okay, so we have written our this function. Let me go through this code again once more. So we have this predict function which will take a file, that will be our image, with the help of this post. We'll again create this with the help of io.bytes io. So when we get this image with the help of this post function, it will not of a image shape. Okay, this will not know, this post request will not know that it is a file or an image. Okay, obviously it will know a file, but what kind of file? So we need to tell this io.bytes io. We will use this to pack the image as well, so we'll again use this to unpack. When read the numbers or the digits which will come from our canvas.py, convert it to grayscale and resize it to 28 cross 28. Then we do this auto contrast thing which we have done in our model. Then we'll convert it to our numpy array and divide by 255 for normalization purposes. Then we'll just save it to see that what we are getting here. We don't need this for prediction, but we are doing it. Then we'll convert it to tensor, do these two squeezes to add the channel and the batch dimension, and then with this torch.nograd we'll do the prediction. Okay, torch.max output 1. Fine, and there we go. So what's left now? Did I explain everything which I have written? So now I'll simply run this. If name is equal to main uvcon.run, host will be 0000, not 30, there will be 40, port will be 8000. Okay. Oh yeah, I haven't explained this uvcon and these whatever I have imported. So you know what this numpy is. Obviously I won't explain this. Okay, FastAPI is a framework which will help you use simply Python based APIs. And this HTTP exception is whenever we are getting any exception or any error, so it will handle these HTTP exceptions. Upload file will help us getting the images. And again, this window library, we have talked about it in the first video. We have this input output library, that is IO. Torch we have seen in our previous videos where we were training the model. And UVCon is the server library which help us to run this FastAPI through a server. Okay, OS you know, torch.nn.functional as of that on you know. So our server is ready. Okay, I hope it works. So let me try to run it. Also you will need to install some of these libraries, pip install, so you can just try these commands. I have already run these commands because installing some of these libraries may take some time, so you can just do these things, run these commands, and you will be good to go. Fine. So let me run this. Python model server .py. It will take some time. This system is slow. Let's go back to this canvas.py where we need to change this predict digit function. And what we need to do, we need to hit this API which we have just it is running. It will take some time, so we need to hit that API. Okay, so let me create here one server URL. Okay, so server URL, localhost, or you can write 127.0.0.1, both are same thing. And we remove this, that will be our server URL, and then we'll do a prediction endpoint. Okay, so predict endpoint. I am doing this so if in future we'll change these endpoints and or we need to add other endpoints, we can have this one server URL and then we can have multiple endpoints like save endpoint or retrain endpoint. So for now we are using this predict endpoint. Okay, slash predict. Fine. And meanwhile our model is also up and running here. Okay, so we can hit it from our this predict digit function. So what I do now, I'll command these placeholders. Okay, and now I'll do help this use this io.bytes io, as I say that we'll use this to pack our image. Okay, send.image.save output format png, and okay, then what we'll do this output.seek0. I'll explain what we are doing, and then I'll have this URL which is equal to server URL predict endpoint. Okay, and then I'll hit this. Yeah, let me have the image data. Oh, it's already here. Okay, and then I'll hit this API. So for that we'll use response. Response is equal to request dot post. Okay, so till now what we are doing, we are using this io.bytes io here, so it will create a stream. Okay, and whenever this bit indent will end, the stream will end. So what will this bytes io will do, this it will take this image, and it is saying that okay, the format is of images of png, and then it will create an output which will be a sequence of the image, or basically what it will do, it will take the image and convert it to a sequence of numbers. Okay, so let's say you have 28 cross 28 image, and then it will 28 cross 28 whatever that is, it will create a sequence or an array of those many numbers. Okay, and what is this output dot seek 0 is doing? So when we create this array, it will start from here and go till end, right? Because we were encoding our image, so from first pixel to the last pixel it will go till the end. So when we are doing this output dot seek 0, again we are coming to the first element of the array. Okay, then we are creating our server. So we have this server URL and our endpoint. So we have created our URL, and image data we are getting from this output dot get value. So it will get this array or a sequence of the numbers. Then we are using this request to hit our endpoint or our API with this URL. Also we are sending this file, that is our image data, that is our sequence, right? And what will happen, it will hit here on this endpoint, and this file, that will be a io.bytes.io file, and we have closed it here, we have sent here, and then we will read this file with again help of this bytes.io and convert it again to size 28 cross 28. Okay, I've gone many times through it, but it's okay, you need to understand it. Fine. Then what we'll do, because we have just sent this data, so we'll check if our response status code is 200. Okay, that means that our if response.status code is equal to 200 means our API has successfully hit and it has returned something without any error. We will do this prediction is equal to response.json.get predicted digit. Okay, which we were sending back predicted digit, and message.showInfo, that prediction, here is your prediction and the prediction. Okay, otherwise what we'll do, hence we'll have that failed to get prediction from server, we'll get some server error. Fine, so this should do it. Okay, our server is already up and running. Okay, let me go through the code once more. So we use this io.bytes.io to convert this image in a sequence or an array, and then we have used this our endpoint, and we are hitting this API, we are getting the prediction, and let's say if it works or not. So I'll open another terminal. Okay, and I'll simply run this canvas app. So python canvas.py. Okay, so we got our canvas. Moment of truth, let me draw something. So I have drawn a 7. Let me click on predict and see what happens. Okay, so we have got wrong prediction. Let me try something else. Let's say 6. Okay, so here is your prediction, it is saying 6. Let me try 5. Here's your prediction, that is 5. Okay, it's working. Let me try 4, and it is saying it is 4. Let me try some more. Let's say 1. Okay, let's say 0. Okay, 0. Perfect. So what happened to the 7? Let me try once more. Let's say 7. Okay, so 7 it is not predicting correctly, I don't know why. Let me try 3. 3 it is predicting. Okay, then what is wrong with 7? Why it is not predicting 7 only? Okay, so there's something wrong with the 7, and what you can do next, because there will be difference between the images which we have trained our model, that is of MNS dataset, and the image which we are drawing here. So here we are getting this image temp.image. So I'll just keep it here so we can see that what we are putting here, how is it looking, what our model is actually seeing. So let me do something like, what digit left? 8. Okay, so it is printing 6 and it is something looking like this. So there is some difference. It is not obviously 100% accurate model, but you have seen that fairly it is like somewhat 80% it is predicting correctly. So yeah, this is it. We have created our model. What you can do next, that you can create a feedback loop, because there's a difference where which images we are feeding to our model for prediction and the images which we have trained. So you can use a feedback mechanism that whenever this any wrong prediction our model is doing, we will store those images and the true level. So you can add a, if any image is mispredicted, then you can specify its true label and save that image, and whenever you have enough images you can retrain the model. It is called a feedback mechanism, and so we can implement that in future videos if you want to. For now, enjoy this. For now I guess it is still giving pretty good accuracy. Okay, so see you in some next video. If you have any questions, shoot it in the comments, and bye.